So Alex, what advancements in AI or ML excite you the most? What do you see on the horizon?
Yeah, so there's a lot of really cool advancements that are happening right now. Some of them have to do with how do you learn with less data. And so one of the things that I think we've learned a lot recently with AI ML is that you often need a lot of data to do something. And so how can you learn? How can you teach a model to learn when data doesn't exist yet, for example? And so there's been this whole idea of reinforcement learning. And reinforcement learning kind of comes to the idea of if you have a model play a game, you're almost training a model similar to how you would train like a pet dog. Basically, you say like, oh, model, you did good when X, Y, or Z happens. Like if your score goes up, you did really good. But if your score goes down, like bad boy, like model, you didn't do well. And this has been really cool. It started actually being trained. One of the initial papers on reinforcement learning that was really influential in the field was teaching models how to play Atari games. And so now there's models that basically they'll start playing these games and they're horrible at it. But you train it by saying, oh, having a good score is really good. Or if you're playing Mario, not an Atari game, but Nintendo game, if you keep going to the right, that's good too. And these models learn to be experts at these games. And so you can do the same sort of thing with different problems in any type of business space as well. If we maximize this sort of number, if we minimize the number of times it takes a human to do something, or if we make this more efficient, we can do well. And what's great about this is you're not collecting, you don't need years and years of data. You really can just let the model observe the world around you and make decisions. And so reinforcement learning, all under the umbrella of learning on less data, that's been really cool. There's been these type of networks called GANs, which again work on low amounts of data, but they're doing really cool things. So you're able to take a photo of a person and then kind of overlay it on something else and make someone like dancing, for example. It's just really cool tech that's coming out. And I think, the nice thing about this, and I think what maybe the world doesn't always see around a lot of this technology is that most of the artificial intelligence, machine learning world is open, meaning that all of the research is being published, even research coming from a lot of big organizations is being published in open academic journals, and it's all building on itself. And so really, we're just kind of having this tidal wave that keeps getting bigger and bigger of more and more people reading the research that's being done at all of these different organizations and improving upon it. And additionally, a lot of the AI ML models that people are using today are models that were trained on hundreds of thousands of computers, just in these big computing farms, creating really, really powerful models. And then those models can be used by others. And so those models are even being shared. So a lot of collaboration in this space right now is really exciting. One other area kind of around AI ML that excites me is the explainability aspect. And so we were really content as a field treating models as black boxes for a while. We kind of understood how they worked, but we didn't really care as long as they gave the right answer. But now we're actually diving a lot more into explainability, and reasons why this is really important for us is not only more accuracy in what we do, but one of the biggest kind of concerns around AI ML is the ethics around it. And so by not being able to understand how something works, sometimes a model could create something that's extremely biased and could cause issues down the road that we might not think are ethical. And so this explainability research is really helping us tackle that and be aware of problems that models can have right off the bat. And then the last bit for me, AI ML that excites me is just computing technology is always getting better. They're creating specific hardware chips right now to do AI ML, faster graphics processors, et cetera. And so the amount of work that we can do and the speed at which we can do it is amazing. The kind of things that my team is doing at SurePrep probably would have only been possible to do on probably the biggest computing clusters at universities in the world, even 10 years ago. And so the fact that we can have so much power right now as a company and as individuals is really impressive for how far the hardware has come.
Yeah, I'm glad you brought that up because I was going to mention it. You mentioned powerful models. I was going to ask about powerful computers. Quantum computing seems like the kind of thing that is going to provide like an enormous leap forward. Is that something that you see, on the short term horizon?
I think quantum computing is a little bit further out. I do think there are going to be some really cool aspects, especially in cryptography and keeping data secure, that I think quantum computing can bring. On the shorter term horizon, it's really kind of the way that people have used graphics cards, basically specific chips. Graphics cards essentially do graphics for video games. And it turned out that all of those graphics for video games were matrix multiplications. It's just the same exact math that we're using in AI ML. And so the AI ML world kind of said, oh, we can do all of our processing on these cards. That's the sort of stuff that is really advancing the field right now. And with cloud computing, what's great is my team can buy a giant cluster of graphics cards, 20 or 30 of these things, where each card would cost probably tens of thousands of dollars. And we can borrow it for an hour, use it in the cloud. And then we can say, okay, cool, our model's trained, we're good to go. Now we don't need these anymore, and turn it off. And so we're able to kind of rent these super powered computer clusters for terms of hours, and then not have to use them again. And so it's awesome to be able to share that time using cloud tech.
That's incredible. Yeah. Wow.